Hello. Hello. Hope you all can hear me. We'll start today's tutorial uh, where we will be solving problems from week 11. Okay. So without delaying, we start with the first question, which is asking you to find Laplace transformation of the function ft is equal to 4t square minus t, right? Okay, so to begin with, what are the things we know first? So Laplacian of t to the power n we know as n factorial over s to the power n plus 1, right? And if you like that, this is for n is greater than equal to 1. So when n equal to 0, you just cannot put n equal to 0 here. So when n equal to 0 means 2 to the power 0, which is 1. That is not the same thing, but that will be, sorry, n equal to 0 also, it will be same, okay, 1 over s. So I will write as n is greater than equal to 0, it will hold, okay. And you know Laplacian, this is Laplace transformation, that operator, when it acts on to addition, so it will be L of that plus L of other. So additivity property is there. So now if we apply L of what we want to know, L of ft, right, that is equal to L of 4 times t square minus 3, okay, that is equal to L of 4 times t square minus L of 3. And we know any constant, if you have in a Laplace transform inside that, that can come out. So here also similarly this. Now you know Laplace of t to the power n is n factorial over s to the power n plus 1, right? Minus 3 times, this is 1 we think as t to the power 0, right? Then it will be 0 factorial, which is 1 over s, right? What does that gives? 4 times 2 over s cube minus 3 over s. What is that? 8. 4 times 2 is 8, right? 8 minus 3s square over s cube. So that should be the answer. So this is how we should do that. You have 40 square minus 3, but as Laplace transformation is additivity, is like it has a additivity property, so it will just split for as L of 40 square minus L of 3, and then do the usual calculation to get this one, okay. So answer is also given like in the same way I do S cube. So, okay. Now let's move to the second question, which says that what is the Laplace transform of ft is equal to sine square 5t. So what you know is what is L of sine of at, you know, L of So I will not write maybe here. So let's start with this. So what you need to find the Laplace transform from the function ft is equal to sine square 5t. So we do not know about sine square. What we know, L of sine of at, that is nothing but a over a square plus a square, and we also know cos of at is equal to s over a square plus a square, right? So we need to remember this. When it is sine, it will be a over a square plus a square. When cos, it is s will be there, s over a square plus a square. But we know about these two trigonometric functions, okay? But how to evaluate this sine square? It's not like that L of f square will be L of f whole square. It's not, right? So what will happen here? You can write sine square 5t as, let's say I put half times 2 sine square 5t. Okay, but again this one you can write as 2 sine square 5t, right? Okay, so I just want to make it in the sine of 80 form. Okay, so for that we know cos of 2a is equal to cos square a minus sine square a, and if you use 1 minus cos 2a, that will be 1 minus cos square a plus sine square a, that is equal to, this is sine square, so it will be 2 times sine square a. So 2 times sine square 5t can be written as 1 minus cos of 2a. Instead of a, it is 2a, so 2 times 5t, 2 times 5t. Let me write like this for better understanding. So that is half 1 minus cos 10t. See, now we know the formula. So L of sine square 5t is equal to L of half 1 minus cos 10t equal to half L of 1 minus cos 10t, and that is equal to half L of 1 minus half L of cos 10t, that is equal to 1 over 2, and you know L of 1 is 1 over s, as we have done already in 1 by 2 cos of L of cos 10t. L of cos 80 is this, so it will be s over s square plus 10 square, right? What do you get from here? We will have 2s times s square plus 10 square will be 1, not 1, this 2s s square plus 10 square minus s square, right? That is equal to 100 over 2s s square plus 100, that is equal to 50 over s times s square plus 100. You will see s by, so 50 by, it's 50 by s times s square plus 100. It has 50 over s square plus 100, so this is not true, this is minus, this is not true. So this is 100 area, so this is not true, so only this is correct. Okay, done. So this the answer is also written here. Now we move to the third question. Okay, so Which is the following function is or are of exponential order? 1 minute. So when we call a function of exponential order, so if the function is of exponential order, then you can write ft modulus of ft should be less than equal to some constant times e to the power ct. Okay. Okay. So what about e to the power minus t function? E to the power minus t. Yeah. What about e to the minus t? It will be of exponential order because okay. So this is a little difficult to see whether it is. So what another approach is there? If there exists alpha, so that minus of alpha t f t converts to 0. So for this case, you will see, you will find the alpha, let's say 0. Sorry, alpha, let's say half or something, then you get the e to the minus alpha t times e to the minus t tends to 0. So it is of exponential order. But what about e to the 1 over t? Can you find a function e to the power minus alpha t times this one converts to 0 as t tends to infinity? Let's say alpha is greater than 0 first. Okay, so e to the power 1 over t minus, this is 1 over t minus alpha t, right? So that is nothing but e to the power 1 over t times to the power minus alpha t. So as t tends to infinity, this 1 over t converts to 0, so e to the power 1 over t will convert to 1. And as e tends to infinity, alpha is positive, then it will be 0, so it is 0 as t tends to infinity. Right? So all these functions, these two functions are uh, converging to 0. There is e to the minus alpha t for sine also. You will see sine t will converge to 0 as sine t is a bounded function which belongs to minus 1 to 1. If you multiply by e to the power minus alpha t, it will be e to the power minus alpha t sine t less than e to the power minus alpha t. So this converts to 0, this converts to 0, so it should converge to 0 to the minus alpha t. For any alpha positive, you get this converge to 0. So sine t will be of exponential order, right? So similarly, cos hyperbolic t, what is that? E to the power minus x plus e to the power x over 2, right? Sorry, x. So then if you multiply by e to the power minus alpha t, e to the power minus alpha t, alpha is positive, let's say, it will be half e to the minus alpha t alpha x. Okay, alpha x minus 1 plus e to the power alpha, sorry, this will be x alpha 1 minus alpha x. I mean, what you can write, you can see from here, e to the power minus of alpha plus 1 x plus e to the power 1 minus alpha x. As x tends to infinity, how this will be? This one will be this one will converge to 0 if alpha plus 1 is greater than 0, alpha is greater than minus 1. What will happen when it will converge to 0? Because these two functions are positive always. So if positive two function and limit has to be 0 both, then the limit of both has to be 0. So for this it has to be alpha is 1 minus alpha should be less than 0, right? That implies alpha is greater than 1. So in using these two, what you can see that if alpha is a number which is bigger than 1, that will be okay. So with alpha is greater than 1, you can so that e to the power minus alpha x and cos hyperbolic x converges to 0. Okay, that's all. So now move to the question 4. For the existence of Laplace transformation, piecewise continuity and exponential order. So whether you will have Laplace transformation of any functions or not, whether you will get Laplace transformation of any function. If that is the question, that answer will be no, because the existence of Laplace transformation needs this piecewise continuity and exponential order. Yeah, so these two conditions are sufficient, not necessary. Okay, this is sufficient condition to get like existence of Laplace transformation. Okay, so what is the Laplace transformation definition of a function 0 to infinity ft e to the power minus st dt, right? So now, what is how to show existence? For existence, mainly if you can show that ft is less than equal to the power some, sorry, e to the power minus alpha t times ft, it converts to 0, then it is okay, right? These two, otherwise in that interval they will not have any singularity and all. So when exponential order is there, then you can show that it has a Laplace transformation. Okay, I'll not go deep into that. So this is, you study this and get it. Okay, so this will be easy to do. It's the fifth question. See, the function is, no, it is you have to find the function. Laplace transformation is given to you. Okay, let me write L of ft is given to you 1 over s square times s plus 1. And how do you find uh, ft? Right? So ft will be mainly L inverse of this percent function. But you cannot just do it now. So you have to make it easy. The form has to make, you have to make the form simpler, much simpler, right? What you do, we write s squared times s plus 1 is equal to a over s plus 1 plus bs plus c times s plus 1, right? S square. bs plus c over s square. We do usually like this when you have like 1 over s squared times s plus 1, as s plus 1 term is of order 1, so we may take it a over s plus 1, which is of order 0. A is of order 0, and s square, it is of order 2, so we take bs plus c, which is of order 1, right? So then I will try to make, I will try to compare these two. So to compare this, first I assume this, then what will happen? 1 over s squared times s plus 1, one can write as s square times s plus 1 a square, right, plus b times s times s plus 1 plus c times s plus 1. This gives a times, sorry, a plus b times s square plus b plus c times s plus c over s square plus, sorry, s square times s plus 1. So if you compare these, you will see these two are same, denominators has to be same. That implies a plus b equal to 0, b plus c has to be equal to 0, and c has to be equal to 1. That implies b has to be equal to minus 1, a has to be equal to 1. What you get from that, mainly what we are getting from, we'll get from here, what you get 1 over s squared times s plus 1 will be a is equal to 1, so 1 over s plus 1 plus b is plus c, so plus minus s plus c is 1 over s square, right? What does it imply? You can write that this is 1 over s plus 1 minus 1 over s plus 1 over s square. Now can you tell me what is the Laplace transformation of 1 over s square or 1 over s? This will be L of 1, right? This is equal to L of 1 should be this. This should be L of, see, L of n factorial over n plus 1 is, so this will be L of t, right? Because L of t is t to the power 1, so 1 factorial over s to the power 1 plus 1, which is s square, right? So this is minus and this is plus. What about this 1 over s plus 1? If you remember it correctly, it will be L of e to the power minus t. What you get? What is that? 1 over s square times s plus 1 was, so mainly this is equal to this. But 1 over s square plus 1 is given to you that this is L of ft, and that is equal to this whole thing mean L of e to the power minus t minus 1 plus t. So what one can obtain LFT is e to the power minus t minus 1 plus t, e to the power minus t plus 1, e to the power minus t minus 1 plus t. So option 2 will be correct. All other option we can discard. And the answer is given to you for your. So the now sixth question is this. So the transformation is 50 over s to the power 4 minus 625. We don't know any such things, this type of things, unless we know this 1 over s square plus s square type, or s over s square plus s square, or a over s square plus s square. But we don't know about s to the power 4 minus this minus. So what I can write is to the power 4 minus what is 525. What is 625? Is this 25 square, right? Twenty-five. Square mean 5 to the power 4. Yeah, that's what I was looking at. So 5 to the power 4. Then what you can write? 50 over s square minus 5 square s square plus 5 square. So this one, if you see, you can write as s square minus s square minus 1 over, sorry, not a, let it be 5 minus 1 over s square plus 5 square. You will see this will be equal to this, and then we obtain that 1 over See, s square plus s square, it is sine or cos form. S square minus s square you do. S square minus s square, that you do not know. So what is L of cos of 5t? Sorry, not cos, you take sine, because cos has one s. So it will be 5 over s square plus 5 square, right? So that implies L of 1 over 5 sine 5t will be 1 over s square plus 5 square. So one thing we know, this will be 1 over s plus s square minus 5 square. That we are still yet to do. What is that? Minus 1 over minus L of 1 over 5 sine 5t. Now this one, you see, you can write as 1 over 10, 1 over s minus 5 minus 1 over s plus 5. So this one will keep as it is. This is rough. So minus L of 1 over 5 sine 5t. That is equal to 1 over 10. Now we know this is nothing but L of e to the power 5t means e to the power minus 5t minus L of 1 over 5 sine 5t. This one you can show that this is 2 times sine hyperbolic t. So things will be L of 1 over 5 sine hyperbolic 5t minus sine 5t. So sine hyperbolic 5t minus sine 5t. So third option will be correct. 1 over 5 sine 5t. Right. So here is a solution for you, which is done in similar way. Okay, check this. Now I'll move to the seventh question. This is little better. To try to do it the same way I told. Okay. It is like, I mean, so same thing, right? So s square over s minus 1 whole cube. Try to make it like a s square plus bs plus c over s minus 1 whole cube. Okay, so that will be same, right? We have to make it in a like s minus 1 form, okay? So one thing you can do is, yeah, s square you can write as s minus 1 plus 1 whole square over s minus 1 whole cube. That is nothing but s minus 1 whole square plus 2 times s minus 1 plus 1 over s minus 1 whole cube, right? One can write. So that is nothing but 1 over s minus 1. Now you know about this. So plus 2 over s minus 1 whole square plus 1 over s minus 1 whole cube. Now that Laplace transform is e to the power at t to the power n will be so from there you can see right L of e to the power t. So this will be the answer. Okay, e to the power t plus 2t to the power t, and this one will be correct. Answer is also given to you. And move to the next fourth question, eighth question. The Laplace transform of t cube e to the power minus 3t, as you know already have seen. So L of t cube e to the power minus 3t will be, say now t cube is n factorial is t factorial over s to the power 3 plus 1, but here s plus 3 due to this. Let me write it nicely, more precisely. This will be s minus minus 3 to the power 3 plus 1. So that will be 6 over s plus 3 over 4. Third option is correct. See, that's it. Now move to the ninth question. L of 1 over t minus e to the power t over t. So 1 by t times one function is there, then you can write it is difficult. So L of 1 by t times we have 1 minus e to the power t. So what we will do first, we will see 1 minus e to the power t. So that will be 1 over s minus 1 over s minus 1, right? Yeah. So then L of 1 over t, 1 minus e to the power t, then it will be from s to infinity. This quantity means 1 over some dummy variable u minus 1 times tu, right? That is nothing but ln u over u minus 1, that will be from s to infinity. So that is negative of ln s over s minus 1, because at infinity it will converge to ln of 1, that is 0. That is nothing but equal to ln of s minus 1 over s. So ln of s minus 1 over s, so first option is correct. This one is correct. Can see the answer here. So move further, given that f0 is equal to 1, f dash 0, then Laplace transformation of f3t. Okay, so what you all know is the formula for this. L of S square L of F0, right? Sorry, Ft, not F0. It's the third derivative, right? So it will be, the formula is given also for n variable, but we can take for s. So it will be s cube L of Ft minus s square F0 minus s f dash 0 minus f double dash 0, that is equal to s cube L of Ft minus s square times f of 0 is minus s square, s times f prime 0 is 0, f double prime 0 is also s square minus 1. So this would be the answer. Okay, so if you have any question, put in the YouTube channel or ask me personally. Anyway, I'll be replying to all of you. So thank you for your attention.